final exam review. Just like all of the other tests that we have taken, the review for the test is going to be near identical to the actual test itself. The only difference between this review and the test itself is going to be that there might be some different numbers or so, but the types of problems that are on this review and the types of problems that are on the actual final are going to be pretty much the same. Okay, the number of problems is going to be the same, and the number of each type of problem is going to be the same. So in that essence, like I said, the final review and the final itself, if you're looking at the review, you know what to expect for the final. Let's go ahead, let's dig in and talk about each type of problem that we're going to have on the test. The first one here is adding and subtracting polynomials. So find the solution given the operation here and the following polynomial expressions. I'm going to be adding these two together. And what I'm going to do here is I'm just going to rewrite it. Let's do this one up here. So when I rewrite this, I want to put these in descending order, and I want to make sure that all of my kind of x to the fourths line up with, and then my x to the thirds line up, my x squareds line up, and so forth. So that's going to make this top one 2x to the fourth plus 6x to the third minus 2x squared plus x minus 7. And the second one starts 4x to the fourth. I'm going to put that below this x to the fourth here, minus x to the third. But notice I don't have an x squared, so I have to use a placeholder here, plus 0x squared, minus 6x, and then plus 1. All right, I'm adding these together, so I'm going to put a big plus sign to the left here. And when I'm adding, now that everything is nice and lined up, all the x to the fourths in one column, x to the thirds in another column, and so forth, I can just go ahead and add straight down. So 2 plus 4 is going to make 6x to the fourth. 6 plus negative 1 is going to make 5x to the third. Negative 2 plus 0, so that's going to be negative 2x squared. 1 plus negative 6 is going to make negative 5x. The negative 7 plus 1 is going to be negative 6. So my answer for this first one here is 6x to the fourth plus 5x to the third minus 2x squared minus 5x minus 6 matches with that one. All right, the next one I'm going to be subtracting, which is going to be very, very similar. So I'm going to line everything up again, but this time I'll be subtracting. So let's do this one. And it looks like it's the same polynomial expressions, so I can actually just copy these over. 2x to the fourth plus 6x to the third minus 2x squared plus x minus 7, and 4x to the fourth minus x to the third, placeholder 0x squared minus 6x plus 1. Except this time I'm going to be subtracting, so to the left, big minus sign. And now I'm going to subtract straight down. 2 minus 4 is going to be negative 2x to the fourth. 6 minus negative 1, careful with your negatives. This is going to make 7x to the third. Negative 2 minus 0, so negative 2x squared. 1 minus negative 6. So that's going to make 7. Again, careful with your negatives. X. And then finally, negative 7 minus another 1 here is going to make negative 8. So our answer for this one, negative 2x to the fourth plus 7x to the third minus 2x squared plus 7x minus 8. Which brings us to the last problem here for number 1. I'm going to be multiplying two expressions now. To multiply these two, I'm going to set up a box and use the box method. This is 2 terms times 3 terms. So I kind of like to set mine up the long way. Where my 2 terms, 3x plus 4, will go right here, 3x, and then plus 4. And then my 3 terms, x squared plus x minus 2. So for each of these cells in this box, I'm going to multiply to what it lines up with in this column and the row. So this would be 3x times x squared, so 3x to the third. 3x times x is going to be 3x squared. Negative 6x. Down here I've got 4 times x squared, so 4x squared. 4 times x is going to make 4x. And 4 times negative 2 is going to be negative 8. Combining like terms, I see that I've got 2 terms with x squared, and I've also got 2 terms with just an x. So I have to make sure to combine those together. 3x to the third plus 7x squared minus 2x and minus 8. I'm going to select that as an answer. And it looks like I am done with number 1. Any questions about any of these 3? Go ahead and either type in chat, or if you want to ask verbally, you can unmute and ask. All right, seeing no questions, I'm going to get rid of this and we'll move on to number 2. So number 2, we're going to factor each of these polynomial expressions. The first thing I want to do is, let's take a look at this first one here. First thing I want to do is see if there's anything that all 3 of these terms have in common. So 3x squared, 7x, and 4, it doesn't look like it. They don't all have an x, and 3, 7, and 4 aren't divisible by the same number except for 1. So it looks like I can't pull anything out to the front to begin with. The next thing I'm going to do is take a look at my special factoring patterns and see if this follows any of my special factoring patterns. It's not a difference of squares. It's not a perfect square trinomial because 3x squared isn't a perfect square. It's not a cube, so not a sum of 2 cubes or a difference of 2 cubes. So I'm going to have to factor this kind of the long way, if you will. So let's start by rewriting this. 3x squared plus 7x plus 4. And I'm going to say a equals 3 here, and c equals 4. And I am trying to find b equals 7. How I'm going to do that is I'm going to find all the things that multiply, all the integers that multiply together to get 3. And same thing for 4. Well, here it's just 1 times 3. For 4, I would have 1 times 4 2 times 2. But then I also have, because a is not 1, I need the reversals of these. So 2 times 2, the reverse is 2 times 2, so I don't need to write it again. But 1 times 4, 4 times 1. All right, so now it's kind of a matter of guess and check. I know that this is going to factor to a set of 2 binomials. And since 1 and 3 are my only options to get a equals 3, it must be true that one of these is going to be x, and the other one is going to be 3x. I just need to now figure out what else is going to belong in these 2 binomials. Is it going to be 1 on the left, 4 on the right? Is it going to be 4 on the left, 1 on the right? Or is it going to be 2 for both? So I just pick one and we kind of just test it out. So let's try this first one, plus 1 and plus 4. Well, to test it out, you're essentially going to multiply these 2 binomials together. So I create a box where I'm going to multiply x plus 1 and 3x plus 4. And I'll never have to check this box, because those 2 should always multiply to get 3x squared, which will match what you start with here. And I'll never have to multiply this box, because whatever you put here, in this case 1 times 4, will always match this 4 that you start with here. What I'm really testing for are these 2. X times 4 is 4x, and 1 times 3x is 3x. Do these 2 add up to your middle b equals 7? And they do, right? Because 4x plus 3x is going to make 7x. So that means we got lucky on the first try. That is our answer. If we didn't match exactly 7 here, let's say that this was, I don't know, 5x. Well, then I knew that would tell me that these are not correct, and I'd have to go back and try a different combination. But since we got lucky, we know my answer here is x plus 1 times 3x plus 4. All right, now the second one. I do the same thing. Is there anything that these 2 share in common? Doesn't look like it. Okay, well, do they fit a special factoring pattern? In this case, yes. This is a difference of 2 squares. I know this because 25x squared is a perfect square. If I take the square root of that, I get square root of 25 is 5. Square root of x squared is x. 36 is a perfect square, because if I take the square root of that, I get 6. So this is really 5x in parentheses like this squared minus 6 in parentheses like this squared. Now it looks just like this difference of 2 squares, where a squared minus b squared is 5x squared minus 6 squared. Well, that means that 5x is a and 6 is b. If I follow this pattern, I will get 2 binomials, a plus b, so that's 5x plus 6, and a minus b, so that's 5x minus 6. Let's see if that's one of our options for our answers. And it is, right here. So in the case that what you're factoring does have a special factoring pattern, you can just look to your list of patterns, figure out which one it is, and then follow that pattern to see how it would factor. If it does not have a special factoring pattern, then we kind of have to do this long way about factoring, where we've got to do factors of A, factors of C, and then guess and check to find the middle part, B. Questions there? All right, seeing none, I'll get rid of this, and we'll move on to number 3. For number 3, I'm asked to use long division to divide x to the third plus x squared minus 14x minus 24 by x plus 2. Okay, for long division, it's really 4 steps that I have to follow after I set my problem up. So let's start by setting up x to the third plus x squared minus 14x minus 24 is going to go on the inside of this long division problem. And I'm dividing by x plus 2. So that's going to go to the left. So now that I'm set up, I'm going to follow 4 steps. Step 1 is to divide the first term on the inside by the first term on the outside. Divide the first term inside by first term outside. So that's going to be x to the third divided by x is going to make x squared. That's going to go on top. Okay, then step 2. Whatever you put on top, you're going to multiply to the outside. And then you're going to put that below. So x squared times x is going to make x to the third. Notice these two match. This x to the third and this x to the third. X squared times 2 is going to be 2x squared. Now the reason I pointed out that these match is because step 3, you're going to be subtracting. And when you subtract, these two will always match, and they'll always cancel with each other or subtract out to 0. What you're left with is x squared minus 2x squared. That's going to make negative 1x squared. And then step 4 is to bring down the next term or the next terms. So here in this case, I've got one term down below, and I'm dividing by 2 terms. So that means I've got to bring down one more term. So that I've got 2 below, and I'm dividing by 2 out here. Then once you get here, you're just going to go back to step 1, which is first term on the inside. You're going to divide that by the first term on the outside and put the answer on top. So now, since these canceled out, I'm going to have negative x squared divided by x. So that's going to be negative x. That goes on top. Follow my steps, go down to step 2. What I put on top, I'm going to multiply to the outside. Negative x times x is negative x squared. Again, notice that these match exactly. Negative x times 2 is going to be negative 2x. Step 3, I'm going to subtract. When you subtract, these two should always match because they're going to subtract out and go to 0. Negative 14x minus negative 2x, careful with your negatives. This is going to make negative 12x. And step 4, bring down the next term or terms. I've got 2 out here, only 1 here. I'm going to bring down one term, go all the way back to step 1. Step 1, divide the first term on the inside by the first term on the outside. Negative 12x divided by x is negative 12. Step 2, what I put on top, multiply to the outside, put below. Negative 12 times x is negative 12x. Negative 12 times 2 is going to be negative 24. Step 3, subtract. These will always cancel, but it just so happens that negative 24 minus negative 24, these will also cancel, resulting with 0. And since there are no other terms to bring down, I don't have any remainder because I have a 0 here. Now, if this was anything but 0, let's say that this was 3, then I would also need to put, for my answer, not just x squared minus x minus 12, but then plus whatever my remainder is, 3, over what I divided by x plus 2. In this case, since there's no remainder, my answer is just x squared minus x minus 12. Questions there? Okay. Well, I'll clear this then. And since we just did a problem on long division, we're also going to have a problem on synthetic division. So we're going to take a look at that one next. All right, number 4, we're going to be using synthetic division to divide 2x to the third plus 5x squared minus 23x plus 10, and I'm dividing this by x minus 2. So for synthetic division, it's a little bit different of a setup. I kind of set this up, upside down almost, if you will. So I start with a problem that looks like this. And on the inside now, I'm going to put 2x to the third plus 5x squared minus 23x plus 10, but only those coefficients. So those are the multipliers to tell you how many x to the third you have, how many x squared you have. And if you're missing something, you definitely need to put a placeholder. In this case, I'm not missing a term. I'm going from x to the third to x squared to x to know what power of x. So I'm just going to put 2, 5, negative 23, 10. 2 on the inside, 5 on the inside, negative 23 on the inside, and 10 on the inside. Now on the outside, you might be tempted to put x minus 2 out here, but what we actually need to do is we need to take x minus 2, and we need to set it equal to 0. I'm going to solve for x, adding 2 to both sides. And I find that x equals positive 2. So I'm actually going to take this positive 2, and that's what's going to go on the outside here. And I always drop down my first term so that the inside 2 will drop down to right here. This is my setup. Okay, that is all of my setup. And now once I'm set up, I'm going to follow, just like long division had 4 steps, and we did step 1, step 2, step 3, step 4, back to step 1. Okay, and then we just continued on from there. Here I'm going to do 2 steps. The first step is to multiply diagonally to the outside 2. So 2 times 2 is going to make 4. I'm going to put this in the second row. So this 4 goes here. Then step 2, I'm going to add straight down. So 5 plus 4 is going to make 9. And then I just repeat. So multiply diagonally to the outside, put it in the second row. This time it's 9 times 2 is going to make 18. That's going to go here. Add straight down, so negative 23 plus 18, that's going to make negative 5. Start back over, multiply diagonally to the outside, put it in the second row. So negative 5 times 2 is going to make negative 10. Now when you get to this last column, I'm going to switch my color. Because when I add straight down, 10 plus negative 10, whatever number I get here, in this case it's a 0, this tells me what my remainder is. Now in this case, since it's 0, I don't have a remainder. But again, if I had a remainder, such as 3, I'd have to put plus 3 over what I'm dividing by. In this case, I'm actually dividing by x minus 2, okay, at the very end. Now since I don't have that, my answer is simply right here. That's going to be 2. I drop down 1 power from my highest from before. So this was x to the third. This is going to be 2x squared plus, drop down another power, 9x, drop down another power, minus 5, with no remainder. All right, so that answer matches. Oh, it looks like I had a little bit of a typo. That should have been a 2x squared, so apologies. But select x squared plus 9x minus 5. I just forgot to put a 2 at the front there. I'll go back and I'll fix that later. Okay. In fact, what I'll do is I'll write in there for now that this is supposed to be a 2. Okay, that brings us to the end of the first half of the final exam review. This first half is going to look just like the first half of the actual final itself. Okay, how are we feeling about the first half? If the final itself was just this first half, how do you think you would do? Give me a 1 through 5 in chat. You can send it to me in private chat if you want. Okay, 5 being like, I'd do really, really great. 1 being like, oh, not so much. 3 right in the middle. Okay, how do you think you'd do 1 through 5 on the first half? All right, so I'm seeing some 4s and 5s, so that's good. Awesome. Okay, well, let's take a look at the second half then. I'm going to clear this. Again, I'll have to remind myself to edit that later. Number 5. Find the least common denominator for these two rational expressions. So here, the numerators, they don't matter at all. Okay, the numerators don't matter at all. If I'm just doing the least common denominator, I'm only looking at the bottom portion of each of these rational expressions. So let's do this. Let's take the left one and let's put it out here, 2. And here I've got x squared plus 6x plus 9. And here I'll do x squared minus 9. Let's do that right here. All right, what I want to do is I want to factor both of these completely. So what I see is this is going to be a equals 1 and c equals 9. And I'm trying to get to this middle portion where b equals 6. Okay? Well, I really like whenever a equals 1, because that makes it so it's just 1 times 1, and I've got all these other little shortcuts as well. C equals 9, so that's 1 times 9, and then 3 times 3. I don't need the reverse of 1 times 9, so 9 times 1, because this is a equals 1, and on top of that, because a equals 1, I mentioned that we have some shortcuts. Here I can add 1 plus 9 together, see that this is 10, and I can add 3 plus 3 together, and see that this is 6, and since this 6 matches this 6 here, I know that this must factor to two binomials, where 1 and 1 are going to be x, x, and then I'll have 3, 3, plus 3, plus 3, and I've also got this 2 at the very front, so I have to make sure that I've got this 2 here. Another way to write this, since this is 2 times x plus 3 times another x plus 3, I'm going to actually write this as 2 x plus 3 in parentheses squared. All right, this other one, x squared minus 9, this follows a special factoring pattern. This is a difference of two squares again, similar to the one that we had before. X squared, well, that's a perfect square because the square root of x squared is x, and 9's a perfect square because the square root of 9 is 3. So I can actually write this as x in parentheses squared minus 3 in parentheses squared, where if I follow this pattern, a is x and b is 3, so this factors to x plus 3, x minus 3. Now that both denominators are completely factored, where I've got 2 times x plus 3 squared, and I've got x plus 3 times x minus 3, I'm going to take a look at these two denominators and find the LCD. To find the LCD, I'm going to look at the factors between the two and find the things that they have in common. So they both have a factor of x plus 3 in common. In this case, I've got x plus 3 squared up here, so to the second power, and only x plus 3 to the first power down here. For my LCD, I only need to write this factor one time. So I write x plus 3 once, but I'm going to take the highest power among all the denominators I'm working with. So in this case, this is going to be the second power. Then I copy over any other factors that they don't share in common. So I see this 2 is at the very front here. There's no number or 2 at the very front here. So I have to copy this 2. And I also see that this bottom denominator has an x minus 3 that isn't shared with the top. So I also have to make an x minus 3 here. The LCD then is 2 times x plus 3 squared times x minus 3. Now, knowing how to find the LCD is going to be very helpful because in the next couple problems, I may also need to find the LCD as just one of my first steps before moving on and doing something else with it. Okay, and that's because this next problem is going to be where I'm going to add two rational expressions together, and I won't be able to add them together until I have a common denominator. So what we're going to do here is I'll give you a moment to finish writing this down. I'm going to clear this and we'll take a look at number 5 where that's the case. All right, let's clear this up and let's take a look at the next one. So I'm looking at number 6 then. Number 6 is add the rational expressions. Now you'll notice here that this problem is actually a little bit better, easier, if you will, than some of the problems you did on your assignment. Okay. In this case, I have to find my LCD first because I'm adding two kind of fractions together. If you think of these as fractions or fancy fractions, this is 5 over x minus 4, 1 over x plus 1. Well, since both of these just have a single factor, x minus 4, x plus 1, okay, I've got x minus 4 here, x minus 1. Well, it must be true that the LCD is just x minus 4 times x minus 1, because they don't have anything in common, and when I copy over the things that they don't have in common, it's exactly what they are to begin with. So x minus 4, x minus 1. Now what I'm going to do with this is I'm going to rewrite my problem, but give myself a little bit more space here. So I've got 5 over x minus 4, and I'm adding 1 over x plus 1. As we know, I can't add fractions unless they have a common denominator, so I'm going to compare the denominator that's here to the LCD and multiply both the top and the bottom by what's missing. So I've got x minus 4 here. What's missing is x minus 1. So I'm going to multiply by x minus 1 to the top and the bottom. Same thing over here. I've got x plus 1. Okay. Oh, this is actually x plus 1. This one. Nope. So I've got x plus 1. I'm missing x minus 4. So I'm going to multiply by x minus 4 to the top and the bottom. Well, the result here, 5 times x plus 1, that's going to make 5x plus 5 over, we'll just keep these x minus 4, x plus 1, plus 1 times x minus 4, so that's going to be x minus 4, over, we'll just keep these as x minus 4, x plus 1. So now I can see that these two have the exact same denominator, and as such, I can actually add them together. When I add them together, the denominator will stay the same. And add the numerator. So 5x plus x is going to make 6x. And 5 plus negative 4 is going to make positive 1. So this is 6x plus 1 over x minus 4 times x plus 1. All right, we've got 2 more problems here. Clear this. Number 7. Now I'm going to be multiplying the rational expressions. When I multiply rational expressions, I'm going to multiply the tops together and I'm going to multiply the bottoms together. So that means for the numerator, it's simply going to be 5 times 1. I've got 5 times 1 for the numerator. Five here. But the denominator is going to be x minus 4 times x plus 1. To do that, I have to do a box. X minus 4, x plus 1, it's going to be x squared plus x minus 4x and 4. So I've got x squared minus 3x minus 4. Now this is if I wanted, to show that these two multiplied together equals this. In this case, my answer here is just showing that it's x minus 4, x plus 1. So my answer is simply here. 5 over x minus 4, x plus 1. If you wanted to be a little bit more complete, you could say that x minus 4 times x plus 1 is x squared minus 3x minus 4. But in this case, it is unnecessary. So when you're multiplying two rational expressions, you multiply the numerators, you multiply the denominators. Whatever you multiplied for the numerators, that goes on top. Whatever you multiplied for the denominators, that goes on bottom. In this case, since it was a time test, I made it so here you can just put the denominators together like x minus 4 times x plus 1 rather than actually multiplying them out. All right, and then the last one, of course, if we multiply rational expressions, we must also have a problem where we're going to divide rational expressions. So in this one, we're going to divide x plus 1 over x minus 1, and I'm dividing that by x plus 3 over x minus 2. Well, dividing rational expressions is nearly the same as multiplying rational expressions. In fact, you can turn it into a multiplication problem by flipping your second rational expression upside down. So the reciprocal would be x minus 2 over x plus 3, and I would multiply by that rather than divide by what's shown here, x plus 3 over x minus 2. So I'm going to turn this problem into x plus 1 over x minus 1 times the reciprocal here, x minus 2 over x plus 3. Well, the LCD, since this is just one factor, x minus 1, and this is one factor, x plus 3, then the LCD is x minus 1 times x plus 3. So what do I do there? I'm going to compare each denominator to what the LCD is showing. Oh no, I'm sorry, we don't need this. We're multiplying, we're not adding. We're just going to multiply the tops together. Okay, sorry about that. We're going to multiply the tops together, so make a box for the top. X plus 1, x minus 2, top. We'll have x squared minus 2x plus x, and then minus 2 here. So this will be x squared, combine like terms, minus x minus 2. Bottom, so the denominators, have x minus 1 and x plus 3. And x squared plus 3x minus x and plus 3. X squared minus 2x, no, plus 2x, and then 3. So this over this, x squared minus x minus 2 over x squared plus 2x. Oh no, that is minus 3. Negative 1 times 3. So that is this one here. And that is it. Okay, that is it for the final exam review. If you can, if you followed along and you felt like you were understanding that fairly well, hopefully it means that you're going to do well on the actual final itself. Now, I asked how you kind of felt about the first half. I'm going to ask how you feel about the second half. So for 5, 6, 7, and 8, give me a 1 through 5 in chat. How are you feeling about the second half? 5 being like, definitely got it. Okay, going to do really well. 1's like, I don't really get it at all. 3 is somewhere in the middle. Okay, where are we at? Okay, looks like we've got mostly 4s and 5s, couple of 3s sprinkled throughout. Okay. Now for the people that maybe joined us a little bit later, I'm going to go through each of the answers that we got, and then after that we'll head to lunch. So for number 1, we were adding, subtracting, and multiplying polynomial expressions. Here when we added these two together, we got 6x to the 4th plus 5x to the 3rd minus 2x squared minus 5x minus 6. When we subtracted, we got negative 2x to the 4th plus 7x to the 3rd minus 2x squared plus 7x minus 8. And when we multiplied these two together, we got 3x to the 3rd plus 7x squared minus 2x minus 8. Again, if you weren't here for the beginning portion, if you arrived to class a little late, make sure that you get these answers marked down, as this will make it so that you get these points for the test review, and ultimately these are actually points on the final itself too. Number 2, I was factoring for number 2, so I factored this first one to x plus 1, 3x plus 4, and I factored this second one to 5x plus 6, 5x minus 6. Number 3, I did some long division, and once I had completed that, my answer here was x squared minus x minus 12, which was x to the 3rd plus x squared minus 14x minus 24 divided by x plus 2. For number 4, I did synthetic division, where I divided 2x to the 3rd plus 5x squared minus 23x plus 10 by x minus 2, and I found that the answer is x squared plus 9x minus 5. Here, this is actually supposed to be a 2x squared. I just had a slight typo there, so make sure that you understand that this is supposed to be 2x squared. Number 5, I found the LCD, the least common denominator, between these two denominators, and it was 2 times x plus 3 to the second power times x minus 3. Number 6, when adding these two rational expressions together, I first found the LCD, multiplied each of the rational expressions by what was missing in the LCD, and then added them together like I would fractions that have common denominators to find 6x plus 1 over x minus 4 times x plus 1. Number 7, I multiplied these two rational expressions, multiply the numerators together to get 5, multiply the denominators together. Here I just listed this as x minus 4 times x plus 1. And lastly, when I'm dividing rational expressions, I'm really multiplying by the reciprocal of the second expression. So instead of dividing here, I would say times x minus 2 over x plus 3, multiply through the numerator and the denominator. Whatever you get for the result of multiplying the numerator, put that on top. Denominator, same thing, put that on bottom. In this case, this was x squared minus x minus 2 over x squared plus 2x minus 3.